Following the destruction of Goji Center's out-of-control Indominus II by the hands of Apollyon, the world believed the nightmare was finally over. Yet little did they know, the true horror had only just begun. These deadly creatures forged from the fusion of ancient insects and potent venom swept through ecosystems with ruthless efficiency. Apollyon colonies spread rapidly, consuming everything in their path and defying every attempt to contain them. Conventional weapons and containment strategies failed, and time was running out. To turn the tide, scientists concluded that only a new hybrid designed to infiltrate and destroy Apollyon colonies from within could restore balance. They had to act swiftly before the Apollyons underwent their next nuptial flight and the devastation escalated beyond control. And that's where our story picks up today. Hello everyone, and welcome back to Creature Archives. In this video, we will be designing the hybrid to hopefully put an end to Apollyon's rule once and for all. Before we dive into this video, if you haven't seen the previous two videos in this series yet, be sure to check them out now by tapping on the cards on screen or going to the links in the description. In the first video, I go into the creation of Apollyon, its genomes, and how it was tailored specifically to defeat Goji Center's Indominus II. Then, in the second video, we explore the aftermath and consequences of Apollion's creation, as it escaped the islands and began reproducing on the mainland. Alright, let's not waste any more time. Designing a hybrid to eliminate Apollyon requires extreme precision. There's no room for mistakes. It has to be specialized, efficient, and most importantly, it needs something Apollyon didn't have: strict limits. This new hybrid's entire life cycle must be tied to one clear mission: the total destruction of Apollyon colonies. And once those colonies are wiped out, the hybrid itself must die off, ensuring it can't become the next uncontrollable nightmare. Taking down Apollyon is no simple task. You might think, why not just create a predator, a super hunter designed to wipe them out? But this approach runs into some serious problems. First, Apollyon colonies can number in the hundreds or thousands. A single predator, no matter how strong, would be quickly overwhelmed or driven off. Second, designing a predator that only hunts Apollyon is nearly impossible. Natural predators tend to go after whatever prey is easiest and most abundant, meaning any generalist predator would likely switch to easier targets, leaving Apollyon unchecked. So instead, we're taking a different route, building a hybrid that needs Apollyon to survive. Think of it like a parasite or social infiltrator that depends on Apollyon colonies to reproduce and raise its young. This hybrid won't just kill Apollyon, it will replace it from within, collapsing colonies from the inside out. And that's why these first two genomes, while unexciting, are so crucial. We begin with the foundation of our hybrid, two species that may seem worlds apart but are critical to its ability to both survive and operate within an Apollyon colony: the ancient giant dragonfly Mega and the highly social fire ant. Mega contributes the core body plan, a massive aerial insect adapted for high-speed maneuverability, visual precision, and efficient predation. Its physiology provides more than just mobility, it also offers the metabolic and developmental scaffolding necessary for a unique two-stage life cycle. Much like Apollyons, our hybrid will begin life as a nymph, an aquatic or semi-aquatic juvenile stage. These nymphs will require care and protection during development, paralleling the Apollyon's life cycle. The Mega genome allows us to preserve this complex transformation from aquatic hunter to airborne infiltrator, ensuring the hybrid's life cycle remains synchronized with the Apollyons it depends on. But infiltration requires more than mimicry, it requires communication. Apollyons, like their fire ant ancestors, operate as eusocial colonies bound together by a sophisticated web of pheromones. These chemical signals regulate everything from territorial defense to the rearing of brood, and to exist within this society without triggering alarm, our hybrid must be able to speak their language, at least in part. That's where the fire ant genome comes in. Fire ants possess one of the most refined chemical signaling systems in the insect world. While the hybrid won't yet be able to fully replicate Apollyon-specific pheromones, the fire ant's chemical toolkit provides a broad-spectrum communication base. Think of it as a chemical bridge, a platform that future genomes will refine and specialize. Without it, the hybrid would have no chance of navigating the subtle pheromone-driven dynamics of Apollyon hives. Together, Mega and fire ant don't just form the structural and chemical foundation of our organism, they establish the hybrid's ability to survive, develop, and function within the unique ecosystem of an Apollyon colony. Every genome that follows builds on this framework. Without them, infiltration would be impossible. Our next genetic inclusion shifts the strategy from survival to subversion. Meet Polyurgus breviceps, the Amazon ant, one of nature's most specialized parasites. These ants are infamous for their slave-making behavior. Unlike most eusocial insects, Polyurgus cannot live independently. They've lost the ability to care for their own brood and even to feed themselves. Instead, they infiltrate colonies of related ant species, assassinate the reigning queen, and chemically hijack the social structure. Once the colony accepts the intruder as their own, the enslaved workers continue to work. This behavior is not just fascinating, it's fundamental to our design. By incorporating polyargus DNA, we ensure our hybrid behaves not as a predator, but as a parasite, a living infiltrator that cannot survive without its Apollyon host. It won't just coexist, it will depend on Apollyons to raise its nymphs, tend its brood, and maintain its life cycle. The moment Apollyon disappears, the hybrid does too. No other species on Earth could care for it. This self-limiting biological dependency is key to avoiding the ecological disaster that would come from releasing a runaway super predator into the wild. But infiltration requires more than mimicry. It demands total takeover. And that's where one of Polyargus' most extraordinary abilities come into play. After eliminating the original queen, a Polyargus queen absorbs the chemical signature, the pheromonal identity of her victim. This identity theft...
Identity theft is not a joke, Jim. Millions of families suffer every year.
...allows her to be accepted by the colony as the new matriarch. The workers continue their task as if nothing has changed, now serving a parasite who looks, chemically speaking, exactly like their lost leader. By integrating this into our hybrid, we don't just enable it to survive within Apollion's colony, we give it the tools to replace the queen herself, turning the colony into a puppet force raising the hybrid's own brood. So far, we've laid the biological foundation, a Meganera-like body capable of flight and nympho development, fire ant pheromone systems to facilitate communication, and the Amazon ant's behavioral blueprint for parasitizing and replacing the queen. But now comes a major tactical challenge. Even with fire ant-derived pheromones, Apollyon colonies would almost certainly still see our hybrid as an invader. After all, real-world ant colonies wage relentless war against other colonies of their own species. Kin recognition is highly specific. Unless the scent signature is exactly right, intruders are attacked without hesitation. And against a colony of Apollyons armed with venomous harpoons and lightning reflexes, one mistake would be fatal. Our hybrid wouldn't survive long enough to reach the queen. To overcome this, we turn to a master of chemical deception, the Palus Beetle, also known as the ant nest beetle. Palus species have evolved to live deep within ant colonies as obligate social parasites. They produce highly specialized pheromones that suppress the aggression of ant workers, essentially pacifying them. These chemicals act as a kind of social tranquilizer, preventing the host colony from reacting defensively. In many cases, Palus beetles not only avoid being attacked, but are groomed and fed by the ants, sometimes through trophallaxis, a mouth-to-mouth food exchanging behavior typically reserved for colony members. This isn't just camouflage, it's psychological warfare at the molecular level. Incorporating Palus genetics gives our hybrid the chemical tools to go beyond mimicry and actively manipulate the behavior of the Apollyon workers. Instead of fighting their way in, the hybrid can simply walk through the front door unharmed, unchallenged, and accepted. That's especially vital because of the hybrid's vulnerability. A single harpoon from an Apollyon could be instantly lethal. Chemical invisibility isn't optional, it's survival. What's more, Palus beetles don't just survive in these colonies, they thrive. They undergo their entire larval development inside the nest, feeding on the hemolymph of the host brood or even through social interactions with adult ants. This deep integration into the colony life cycle makes them the perfect model for a species that must embed itself fully within an Apollyon hive. Fascinatingly, Palus beetles exhibit rapid adaptive radiation. In Madagascar, for example, different beetle species have undergone large-scale phenotypic shifts to adapt to entirely new hosts. This evolutionary flexibility suggests that their pheromone systems can be tuned over time to match a wide variety of hosts, a critical advantage when designing an infiltrator for the genetically complex Apollyon. In short, Palus offers the solution to one of our biggest problems, how to get close to the queen without being killed. With its genome in the mix, our hybrid becomes a true infiltrator, not just tolerated by the colony, but chemically embraced. At this stage in our design, the hybrid is fully capable of infiltrating an Apollyon colony. It can pacify workers, replace the queen, and even redirect colony behavior to raise its own brood. But that doesn't guarantee the colony's destruction. Here's why. Like Apollyon itself, our hybrid produces nymphs, not helpless ant larvae. These nymphs, thanks to the foundational Meganera genome, are born-capable hunters, fully mobile and able to feed themselves. Apollyon adults may offer some care, but even without it, many of their nymphs would likely grow up on their own. That presents a huge problem. If our hybrid is able to raise its own young without assistance, even after the Apollyons are gone, it risks becoming an independent invasive species. To prevent this, we need a failsafe. That's where the European paper wasp, Palus dominula, comes in. Palus larvae are obligate dependents. They cannot feed themselves at all. They rely entirely on adult wasps to chew and regurgitate prey for them. This dependency is enforced through specific pheromones and behavioral cues emitted by the larvae, which prompts feeding behavior from adults. But here's the key. We are only integrating the larval dependency behavior, not the adult caregiving instinct. This is a very precise genetic addition. one that rewires the nymphs to require care but doesn't give the hybrid adults the ability or instinct to provide it. In other words, the hybrid's offspring will beg for food like wasp larvae, unable to survive on their own. But only Apollyon workers already deceived by chemical mimicry will respond with appropriate feeding behavior. Hybrid adults won't recognize or feed their own brood, even if they tried. This enforced helplessness ensures three things. The hybrid is completely dependent on Apollyon colonies to survive. Once the Apollyons are gone, the hybrid's offspring cannot mature, leading to its self-created extinction. And Apollyon resources are diverted away from their own young, accelerating colony collapse. The Palus Dominula genome isn't just a clever adaptation, it's a critical safety mechanism, a built-in biological leash that guarantees our hybrid dies with its host. It's one of the most targeted and strategic pieces in the entire genetic puzzle. With infiltration protocols complete and colony integration secured, the next challenge becomes actually eliminating the Apollyon Queen. Even with the pacifying chemicals from Palus Beetles, the Apollyon Queen is still a massive and well-defended organism. Apollyon colonies are eusocial and militarized. Should the Queen detect a threat, her defenders will respond with lethal force. A single mistake could doom the hybrid, or worse, alert the entire colony before the Queen is neutralized. So, the next few genomes are specifically chosen to ensure that once a hybrid queen reaches the Apollyon Queen, she can swiftly, efficiently, and silently kill her. First up, the Velvet Worm, an ancient predatory lineage, brings one of the most unusual and effective subduing tools in the invertebrate world: rapid-fire adhesive slime. Velvet worms immobilize prey by ejecting sticky mucus from specialized projections called oral papillae. This substance hardens almost instantly on contact with air, entangling and disabling even fast-moving prey. By incorporating this genome, our hybrid gains a non-lethal first strike mechanism, an entangling mucus spray that can be used at close range to immobilize the Apollyon Queen long enough to prevent her from escaping, fighting back, or summoning soldiers. It's a form of biological crowd control, silent, chemical, and immediate. But immobilization is only the first step. Now the Queen must be eliminated and replaced with precision and speed. Assassin bugs are infamous for their gruesome yet efficient killing method. They inject a liquefying enzyme cocktail into their prey, turning organs and tissues into soup, which they then siphon out with a piercing rostrum. This ability allows them to kill large or armored insects quickly and with minimal struggle. By adding the assassin bug genome, the hybrid gains a piercing rostrum-style harpoon that can stab through the Apollyon Queen's carapace, a gland capable of producing potent liquefaction enzymes to kill the Queen from within, and feeding behavior that allows the hybrid to consume the Queen's internal fluids, including the gland responsible for Queen pheromone production. This is critical. In polyergus ants, the invading Queen must absorb the original Queen's pheromone signature in order to be accepted. Our hybrid will do the same. Feeding on the Queen's liquefied body will allow it to chemically impersonate her, completing the replacement process seamlessly. With the genome complete, we now unveil the culmination of precision bioengineering, a living scalpel forged in the fires of necessity. A creature with no future of its own, bred only to end another. A final failsafe against an apocalypse we created. Codename, Achilles. Scientific name, Insidiator reginophagus, the ambusher queen-eater. Where Apollyon was made to hunt giants, Achilles was made to dismantle empires from the inside out. Achilles is a deceptively elegant predator, an engineered amalgam of precision, infiltration, and biological sabotage. Its overall body plan appears as a sleek hybrid between a wasp and a meganera, boasting a long segmented thorax that provides extreme flexibility in tight confines, with reinforced muscle clusters enabling sudden burst of speed or stability during attacks. The wings are elongated, membranous, and iridescent, visually similar to meganera, but supported by a sturdier thoracic structure derived from eusocial wasp. When folded, they tuck flush against its armor to minimize noise and drag. Its legs are multi-jointed and claw-tipped, capable of both delicate manipulation and iron grip grappling, modeled after the predatory dexterity of wasp and assassin bugs. Thin filaments and tactile bristles along its limbs allow it to read environmental chemical traces and vibrations. The head is an unsettling blend of insect and alien design. Two enlarged, rounded antennae, a legacy of the ant nest beetle, sit like domes atop its head, scanning the air for pheromone signatures. These antennae are hypersensitive, allowing Achilles to detect colony cast, behavioral shifts, and chemical alarm cues in real time. Flanking the mouth are two external oral papillae, derived from the velvet worm. These flexible muscular projections can rapidly oscillate to spray entangling mucus in a wider focused arc. The adhesive is pressure ejected and hardens upon contact, enabling it to immobilize targets like the Apollyon Queen before striking. The mouth itself is a modified assassin bug-style rostrum, a rigid tubular piercing organ capable of injecting enzyme-rich venom into immobilized prey. Once deployed, the rostrum liquefies internal tissues for rapid consumption and pheromonal absorption, allowing Achilles to chemically replace the Apollyon Queen post-assassination. Its reproductive system is uniquely parasitic. Females produce helpless larvae incapable of self-feeding thanks to precise splicing from Palus Dominula. These offspring must be fed via trophallaxis and meat provisioning, task only Apollyon workers are biologically suited to perform. Without a functioning Apollyon colony, these nymphs starve. This ensures that Achilles is an evolutionary dead end by design, a scalpel that dies once the infection is cured. Insidiator Reginophagus was not made to survive, a parasitic ghost born from the sins of its creators and fated to haunt only the nest of monsters. In the labs, Queen Achilles had been cross-tested exclusively with Apollyons to confirm that its chemical signatures would be accepted. They were. Humanity could only hope this acceptance would hold true in the wild. Pooling their resources, scientists identified the highest density Apollyon zones to release the Achilles queens. Carefully, one hybrid queen was released as close as possible to each of these hotspots. Humanity held its breath, eyes glued to monitoring feeds. The Achilles queens wasted no time. Utilizing their Meganeura-derived vision and hyper-developed pheromone sense, each queen swiftly began seeking out Apollyon colonies. The moment of truth arrived as one entered Apollyon territory. At first, worker Apollyons spotted the intruder and surged to attack. But just before harpoons could be fired, they detected the hybrid's chemical signature and were suddenly pacified. Their aggression quelled as if she were one of their own. They dispersed, returning to their duties, allowing Achilles to advance undeterred. Deep within the swampy forest, the Achilles queen located the Apollyon queen. Crawling close, it was met with no suspicion, the Apollyon queen sensing no threat. Then suddenly, spray. The sticky mucus, courtesy of the velvet worm genome, shot forth in a rapid arc. The Apollyon queen struggled against the fast-hardening adhesive, but was soon immobilized. Achilles pressed forward, pinning the queen with its forelegs, the assassin bug rostrum unfurling. A swift, precise jab injected digestive enzymes that liquefied internal tissues. The end was swift. Famished from her journey, Achilles began to suck the queen's liquefied organs and, crucially, absorb her pheromonal scent. In that moment, Achilles chemically replaced the Apollyon queen, becoming the new ruler of the colony. Across the continent, Achilles queens infiltrated Apollyon colonies one by one. Each queen executed the same lethal sequence, replacing the Apollyon queen and unleashing hybrid larvae incapable of independent survival. As these larvae hatched, Apollyon workers unwittingly fed and raised them, hastening the collapse of the colony's brood. Slowly, the Apollyon population dwindled as the hybrids supplanted their young. Not long after, with no Apollyon workers left to care for the helpless hybrid nymphs, the Achilles queens themselves starved, unable to reproduce or sustain their offspring. Their reigns ended as silently as they had begun, extinctions unfolding in the shadows. Humanity watched as one by one, the last Achilles queen laid their final eggs before succumbing to starvation. And with their deaths, so too did the final hybrid nymphs perish, ensuring no lasting trace remained. The plague of the Apollyons was over, but where their deadly wings once stirred the air, only silence remained. Achilles had done its work, swift, final, and unforgiving. And now in the quiet, a fragile world began to heal from a nightmare born of its own making. And that's the story of Achilles, the ultimate parasite engineered to end the Apollyon threat for good. But what do you think? How would you create a hybrid to eliminate Apollyon once and for all? If you enjoyed the video, don't forget to like and subscribe so you won't miss any future content. And a special shout out to our channel members. Thank you so much for your support. Until next time, stay curious, and I'll see you all in the next video.